When you're drawing the SN2 mechanism, there's a maximum of 3 steps that you need to take as you are drawing the mechanism. And in this video, we are going to practice drawing SN2 mechanisms and going over the 3 steps that we have to take. The first thing that you do, and maybe this isn't really a step of the mechanism, the first thing that you have to do is confirm that the substrate, the molecule that is the electrophile in this reaction, confirm that the substrate is capable of doing an SN2 reaction. So we want to make sure the substrate or the electrophile, in a lot of cases it's an alkyl halide, make sure that the substrate is not tertiary. A tertiary molecule is not capable of undergoing an SN2 reaction due to steric hindrance. A tertiary molecule is one where the leaving group is attached to a carbon that does not have any hydrogens on it at all. So the leaving group is attached to a carbon that doesn't have any hydrogens. In both of these molecules, our leaving group is attached to a secondary carbon that has 1 hydrogen present, and secondary carbons are capable of doing SN2, so both of these molecules are valid SN2 molecules. You might be wondering how do I know when I look at this molecule, how do I know where the leaving group is? And to answer that question, the leaving group is typically the only part of the molecule that's not carbon or hydrogen. So in this case, the bromine is a leaving group and the OH is a leaving group. So once you have verified that your molecule is capable of undergoing an SN2 reaction, the next thing that you have to do is check your leaving group and make sure that it is a good leaving group. Good leaving groups are molecules or substances that when they leave the molecule, they're going to be stable and non-reactive. So we have to think about what will these substances look like when they leave the molecule. Things like bromine, when it leaves the molecule to form bromide, that's a great leaving group because it's a very inert, stable, unreactive substance. But hydroxide, not so good of a leaving group. Hydroxide, as you know from general chemistry, is a strong base, which means that it's a very reactive molecule, and that makes it a bad leaving group. So if we have a bad leaving group on the molecule, we have to make it good. And the bad leaving groups that we're going to encounter the most often is OH, as you've seen, and then also NH2, which we'll see in some later examples. If the leaving group is either one of those things, which is bad, we have to turn it into a good leaving group before the reaction can actually take place. And to do that, we are going to protonate, that's a big word, protonate with an acid. What does protonate mean? That just simply means that we are going to add H+. Remember, proton is our abbreviation for the H+ ion. So to protonate something means you're just going to be adding H+ to it with an acid. So let's actually do that step. For these 2 different reactions, because we have OH as a leaving group up here, the very first thing that we have to do is protonate that leaving group with an acid, and we just happen to have some hydrochloric acid ready for us. How does the protonation take place? Well, remember there are 2 lone pairs of electrons on the oxygen. One of those lone pairs of electrons is going to reach out and grab the hydrogen of the HCl, break the hydrogen-chlorine bond, and that is going to leave us with this protonated oxygen. It has an extra hydrogen on it, and because of that extra bond, it has a positive formal charge. And also, when we broke the HCl bond, we were left with a Cl- that was produced by that. So this is not the product of the reaction. This is just us getting this molecule ready to react by giving it a good leaving group. The protonation is not needed for this molecule because our leaving group on this molecule is bromine, not OH minus and not NH2 minus. So it doesn't need anything done to it. Once your leaving group is ready, or if your leaving group is already ready, then step 3, we are going to attack the carbon that's holding the leaving group with our nucleophile. And at the same time, we are going to break the bond between the carbon and the leaving group. So let's practice that. Let's start with the first reaction up here. Our nucleophile is the Cl-. We are going to attack the carbon that holds the leaving group with that nucleophile, and we are going to break the bond between the carbon and the nucleophile. When that bond breaks, the electrons of that bond go on to the immediate atom, so in this case oxygen, the atom that's immediately bonded to the carbon that's being attacked. The electrons go on to that atom as a lone pair. So what have we made? We bonded a chlorine to that particular carbon, and we broke off our leaving group, which is a water molecule. This reaction is done. How about next reaction down here? We are going to attack the carbon with our nucleophile and break the bond between the carbon and the leaving group. The electrons in that bond go on to the leaving group as a lone pair. And so here we have made a bond between this carbon and the nucleophile, OET, and we also have bromide ion, which was removed from the molecule as a leaving group. Let's practice a couple more. So first thing that we have to do is take a look at the carbon that's holding the leaving group. Remember, that's just going to be something that's not a carbon. So here it is, the carbon that's holding the leaving group, and confirm that it has at least one hydrogen present so that it's eligible to do the SN2 reaction. Step 2, check out our leaving group. Here is an NH2 leaving group. This is a bad leaving group, and we're going to turn it into a good leaving group by protonating with an acid. There is a lone pair of electrons on the nitrogen that can be used for that protonation. So let's draw a picture of what that looks like. Now we have added a third hydrogen to that nitrogen, so it's positively charged, and we have an extra bromide ion hanging out after the protonation is done. The bromide ion is our nucleophile, and it is going to attack the carbon that holds the leaving group and break the bond between the carbon and the leaving group. So we have substituted the NH3 with the bromine. We have some NH3 running around, and that hydrogen on that carbon is still there. I'll draw it in just so it's not confusing. We have one more example. First, find the carbon that holds the leaving group. Here's our leaving group. Find the carbon and make sure that it has at least one hydrogen on it. This one has 2. Double check the leaving group. Our leaving group is chloride. It is a good leaving group. Our bad leaving groups are NH2 and OH, so this is not one of the bad leaving groups. That means nothing needs to be done to that leaving group to get it ready to react. Take the nucleophile, attack the carbon, and break the bond between the carbon and the leaving group. Those hydrogens, 2 hydrogens that I drew, they're still there. And we have a chloride that has left the molecule. Now, in all 4 of these examples, we didn't consider stereochemistry at all, which I'm going to do in some later videos. In this video, we're just going over the basic steps of the SN2 mechanism. Another thing that I didn't talk about in this video is how do you even know that it's going to be an SN2 reaction? And that's also something that I'll talk about in a later video.